A light of wavelength 500 nanometers in air travels through diamond that has a refractive index of 2.4. What is the wavelength in diamond? Okay, so we said 500 nanometers was also a wavelength, and 2.4 was our index of refraction. N is the symbol. So there was a formula we learned before where wavelength equals speed over frequency. Perhaps maybe you'll remember it better as a triangle with velocity at the top, wavelength and frequency. Okay, so that's where you get this from. Now, how do we find the velocity first of all? Well, because remember the velocity of the light in diamond, which is what we're looking for here, is going to be slower than it normally is in a vacuum. To find that, we'll use this index of refraction formula, okay, and we'll just rearrange to find V. So it's actually V equals C over N. C is a constant, the speed of light in a vacuum, 3 times 10 to the 8 meters per second. N, in this case, is given in the question. Okay. As for F, we're going to use this to find F. F equals speed over wavelength. Okay, but the speed here we're actually going to use is the speed in a vacuum. So again, we're going to use C because we want to see. It doesn't matter the frequency if the speed is the maximum or slower, because the frequency is one thing that never changes. Wavelength changes, speed changes, but frequency never changes. Okay. The wavelength here was actually given in the question. So the wavelength of the light when it's not in diamond. This will give you the answer for F, then you have the answer for V, and you can find the wavelength in diamond when it's going slower.